For my ENME 351 final project, I wired up a simulation of a guitar. I did this using 6 buttons to represent each of the 6 open fretboard frequencies that each of the strings play at. E, low E, A, D, G, B, and E sharp. Now, each of these 6 buttons are hooked up to a 5-volt power supply grounded with a resistor and are linked up to 6 individual pins linked to 6 individual digital pin inputs. Now, each of these wires reads whether the button is being pressed or not. And whether that button is being pressed or not indicates whether that button's or note's frequency is outputted by pin 13, the PWM, to a potentiometer, which regulates the volume of the sound, to the speaker where the sound is produced. Now, my project also is set up with a processor that displays an imported image of a guitar fretboard with all 6 strings, and actually glows green depending on which string is being pressed. Now, because of the way I wired my inputs to the speaker, I can actually play certain chords with this setup so long as they don't involve any frets, since my hardware encode does not account for notes played past the first set of strings. Now, the final feature of my project is a thermistor, which actually regulates and modulates the frequencies of each of the 6 individual notes simultaneously. Now, this is done and integrated into my project because of the effect that temperature plays on certain notes. Depending on high or low temperatures of notes, string or instrument's notes will be flat or sharp depending on, or lower or higher than they're supposed to be depending on the temperature. Now, my project shows that when you heat up an instrument, since the instrument itself loses elasticity, it does not resist tension as well, which means that the notes will oscillate at a lower frequency than they're supposed to. I hope that this note or this difference will be more evident in class when I present this, but yeah, that is my final project.